going to mark the 5 heights that we calculated using the mean and the standard deviation on this bell-shaped curve here. And for reference, those values were, when we're 2 standard deviations below the mean, that was 63. 1 standard deviation below the mean was 66. The mean, which is the center of the distribution, is 69. 1 standard deviation above is 72, and 2 standard deviations above is 75. The z-score is the number of standard deviations away from the mean, but it's a signed number, so if it's a negative number, that means we're on the left. If it's a positive number, that means we're on the right. So for example, z equals -2 means that we are 2 standard deviations left of the mean or below the mean. So this 63 would correspond to z equals -2. 66 would be z equals -1. 69 would be right on the mean, so z equals 0. Then, of course, we're 1 standard deviation above the mean, and we are 2 standard deviations above the mean. So z equals 2 is where we end. Once we have labeled this curve, we can find z-scores just by looking at the graph. So for 66 inches, we can see right here that that is a z-score of -1. For 75 inches, we can see that that would be a z-score of +2. And for 64 inches, we'd have to estimate. So I'm going to come in here and identify where 64 would land. It would be between 63 and 66, a little bit closer to 63. So that z-score would have to be between -1 and -2, a little closer to -2. I'm going to say that z is approximately equal to -1.7. It's really like -1 2/3, we would say, but this is a reasonable estimate of that. Now, if we're just given a z-score, that also tells us something about where this value would fall in the curve. If our z-score is -3.5, we know from the fact that it's negative that this would be a value that's well below the mean. And 3.5, if I just look at the graph I have up here, I go down to -2. It looks like 3.5. Maybe this would be -3, -4 out here. Z equals 3.5 would have to fall somewhere around here. And therefore we can see that it is an unusually small value for this distribution, and therefore that would correspond to a height that is unusually short. So even without knowing what height we're talking about, just by knowing the z-score, we can tell that it is unusually short. Both of the height distributions that we looked at are approximately bell-shaped. So what we're about to establish here applies to any curve that's approximately bell-shaped. The 95% rule has to do with what we find when we go 2 standard deviations below up to 2 standard deviations above the mean. If you recall in our first example with the heights of adults in the US and of basketball players, we said that going out 2 standard deviations seems to get almost all of the distribution, maybe not quite all of it. More specifically, we can say that it gets approximately 95% of the distribution. If you don't have a whole lot of dots in your dot plot, that could either mean you get all of them, because 95% can be kind of hard to capture when you don't have very many dots, or it could be that you're only leaving out one on one end or the other. But as the distribution gets closer to bell-shaped, this approximation gets closer to being correct. So recall in the distribution of heights of adults in the US, we had a mean of 69 and we had a standard deviation of 3. So an interval that would capture the center 95% of heights of adults in the US would go from 69 minus 2 times 3, right? Which we found to be 63, up to 69 plus 2 times 3, which we found to be 75. And these are in inches. Now, if we want to do this also for professional basketball players, again, we would be using the X bar and the S from that particular data set, and that was a mean of 77 with a standard deviation of 1.2. So X bar minus 2S would be my lower bound, and X bar plus 2S would be my upper bound. Now we did already calculate these. We did already calculate these to be 74.6 and 79.4, so we're going with 74.6 to 79.4 inches. And sometimes we use what's called interval notation for this. To write this in interval notation, we would use parentheses and put the lower bound first, 74.6, followed by a comma, and the upper bound last, 79.4. So both forms of answers would be perfectly acceptable. You may find that the answer most of the time, if you're looking it up in solutions, would look like this interval notation, or if you're on Wiley Plus, it should make it clear what kind of answer it's looking for.